going to talk about the irreversible process in thermodynamics. Irreversible process. All right. So irreversible mean very fast. This process is very fast. Process mean expansion or compression. Let's say expansion. So we don't talk about the compression today. Let's talk about the expansion, fast expansion. So what happened in this process is like this. So you have a cylinder here, and this is a cylinder. Inside this cylinder you have some gas, and the gas is trapped by the piston here, and this piston we put a weight here. Let's say this is a 100-200 gram weight here to balance the pressure of this gas here. All right, so we have a pressure gauge here that measures this is a pressure gauge that measures the pressure, and this cylinder is a graduated cylinder where we can read how much is the volume. Let's say at the beginning the volume of the gas is, let's say, 1 liter. So this piston is at 1 unit mark. All right, 1 unit mark, and this pressure gauge reads the pressure. Let's say at the beginning it is reading approximately 20 units. So make a table here like this. So at the beginning this is a, let's say this is a volume, this is pressure. So at the beginning, how much is the volume? Volume is 1 unit. How much is the pressure? The pressure is 20 unit. All right, so what you should do is remove this weight suddenly. Just remove it. When you remove this weight, what happens is this piston moves up because of the this gas expands, or the gas pushes up the piston, and this piston moves up like this. All right, so let's say this is a piston, and this piston moved up. When you remove that weight from there, this piston moved up and the gas expand. All right, so let's say this piston went up to and reached to the 4 unit mark, and this pressure gauge reads, let's say, 5 unit pressure. All right, so what is the volume? Now record it here. There's a 4 unit volume and a 5 unit pressure. All right, now you have how many data point? You have just 2 data point. Now what you should do is plot these 2 data point in x and y axis. So let's say plot these 2 data point here in x and y axis. This is x axis, this is y axis. So we have, let's say, this is a pressure axis, and this is a volume axis. This is a 20, and let's say we have somewhere here is the 5, and let's say the volume mark here is 1, and somewhere here is, let's say, 4. All right, so where is our first point? The first point is 120. When volume is 1, pressure is 20. Somewhere here is our first point. And where is our second point? 4, 5. So 4 is here, 5 is 4, 5. 4, 5 is somewhere here. So what happens here is that the pressure, our final pressure is all like this in the 5 unit mark. All right, and our volume was at the beginning at 1. So we draw a line like this. All right, so you see that the pressure suddenly drop all the way to 5. At that time the volume expand like this. So we got a figure like this. You see that we got a figure like this, and we have to find the area under this PV line. So this is a vertical line here which is perpendicular to the this axis. So there is no area under this line. There is area only under this horizontal line. So the area of this rectangle, you see that this is the rectangle, and the area of this rectangle is the work done during this process. See that? So how much is this? This is 5 unit. And how much is this? This is 1. This is 4. So 4 minus 1 is, this is 3. This is 3. This is 5. So this is a rectangle. So what is the area of this rectangle? 3 5s are 3 multiplied 5 is 15 units. So how much work we did? The work done in this process is 15 unit. We did the 15 unit work. So let's do another kind of expansion. Let's put two weight in our piston. Let's say this is a gas, this is a cylinder, and we have some gas here, and this gas is trapped by the piston, and let's say this gas is balanced by 2 weight here. This is 1 weight, and this is another weight. We have 2 weight here, and we balance this gas pressure with the help of the 2 weight. All right, so again this piston is level, and we have a pressure gauge here that measures the pressure. So let's say again we have to make two column here, one is volume column, another is pressure column. Let's say at the beginning the volume is at, let's say, 1 unit mark. Volume is at 1 unit mark, and pressure is, let's say, 60. This is 1, this is reading at 1, and this pressure gauge is reading as 60. So your first point is volume 1 unit, pressure is 60 unit. All right, and let's remove this this piston. When you remove this piston, what happens is that this, with the help because this gas pushes this piston and this weight up, so what happens is this piston moves up like this, and it still has one weight here. It still has one weight here. You see that one weight there. Now let's say this is now is 3. Let's say our piston is somewhere at 3. All right. So, and at this time the pressure gauge reads approximately, let's say, 20 units. So our volume unit become 3, and the pressure unit become pressure becomes approximately 20 unit. The volume becomes about 3 unit, and the pressure become approximately 20 unit. Again, what you should do is remove this block again. When you remove this block, what happens is the piston moves further up there, right? Further up there, and let's say this is now at 5 unit mark. Now the volume is at 5 unit mark, and the pressure is at let's say this pressure gauge shows, let's say, 12 unit. All right, 12 unit. You see, so we have now 3 points. Now this gas is expanded like this in 2 step. So how to calculate the work done in this process? Now I'm going to show how we plot this point here. So draw the graph here. This is a y-axis, this is x-axis. Plot the p values here and plot the v values here. All right. So volume is 1 unit, and pressure is somewhere here is a 60 unit. So somewhere here, the first point is somewhere here 1 and 60. So first point is 1 and 60 here, and the second point is 3 and 20. So somewhere here, let's say 3, and this pressure suddenly drop, and let's say somewhere is this is 20, and somewhere here is another point, let's say 3 and 20. This point is 320. All right, and further what happens is 512. So let's say this is a 5 unit, and somewhere here is, let's say, 12, and somewhere here is you have another point 512. All right, so what you should do is you draw a line like this. You should not draw like this. If you draw a line like this, that becomes a reversible. That's not this is not a reversible process. We did this process very, very fast. So what we should do is we draw a line like this, very perpendicular to this x-axis, like this, and you should connect like this, and then again you should go all the way down like this, and then you should go like this. You see that? You can just draw line. You can draw like this. If you draw like this, that becomes the reversible process. That's a very, 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 very slow infinite process. But we are doing very fast process. That's irreversible expansion of the gas. Now, since this line is a perpendicular line to the x-axis, there is no area under this curve. So we have only area under this curve, under this line and under this line. So what we should do is we just draw a line like this, and and line here. Just draw like this and draw like this, and find the area under this line like this. You see that? So how many? You can just draw a rectangle here like this here, and since this is total 20, this is 12, so this is approximately 8. All right, so this is 3, this is 1, so this is approximately 2. You see that? This is 2. So just this is a rectangle, so multiply 8 and 2. So what happens here is the area of this is 8 multiplied 2 equals to 16 unit. The work in that place is 16 unit. And now the area here, you have to calculate the area of this rectangle. So how much is this area? So from here to here is from 1 to 5, that is, this is 4 unit. All right, this is 4 unit, and this is, you see that, this is at the 12 line, so this is a 12 unit. This is 12 unit. You see, this is 4 unit, this is 12 unit. So work here is 12 multiply 12 multiply, this is 12, this is 4. So 12 multiply 4 equals to 48 unit, 48 unit, 48 unit. You see that in this one we have a work 16 unit, and in this we have a work 48 units. So how much is the total work? 48 plus 16. All right, so the total work done there was, so total work done, total work there was, how much is the work there? So 16 unit in that upper and 48 unit in the lower. So that is, we have to add both together, and 8 and 6 is 14, 4156, so 64 unit. So how much work we did there? 64 unit work we did there. So that's all about the irreversible expansion of the gas. Thank you.